Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Now today we'll be looking at the revision for paper 2. No, you've done paper 1 last week, but let's look at paper 2. I know you're writing your paper 1 next week on Friday on the 4th, and I hope you're ready for that. Now let's prepare for the 7th today. Now we're going to be looking at paper 2. In paper 2, you still remember in paper 2, the structure of your paper will be in this order. Now you're going to have your analytical geometry at 25, but today we're going to be looking at how many marks can we target from these topics. So we're going to look at the analytical geometry, which is 25 marks, but we'll try and target some marks there. There are questions that come each and every year. So there's similar questions that we're going to do similar questions to those ones, and let's see how far we can go with it. So we'll try to target about 20 marks on that. Out of 25, if you can get 20 marks out of that, remember you only need 45 to pass this paper, which is like nothing. We're also going to be looking at trigonometry, which is 50 marks. We are also going to target about 20 marks on this one. On this one, try to target 20 marks. So here we're talking about your 1 hour, the first hour from 9 to 10 o'clock. Those are the marks that you must go and look for in that question paper. And after you have done that, and the rest of the time, the 2 hours, then you're going to try some of the questions that you are not sure of. But these ones are short cases. You have to go and practice these questions. There will be similar questions to the ones that I'm going to do today. Right, and then we're also going to look at the mensuration, the circles, angles, and angular movement. And here we're having 35 marks, and I think we can also target about 20 marks here. So I'm going to show you how we're going to target those marks there. The Euclidean geometry will do it later on. So there, at least if you can target about 10 marks there. So if you check the total marks there, you have 20 there, you have 20 there. So you've got 20, so you've got 60, and you've got 70 marks, and you only need 45. But if you can go and target those marks, you can be able to pass this paper. Right. Now let's look at the analytical geometry. So in analytical geometry, remember in analytical geometry, what you need to be able to do. These are all the things that you need to do to be able to do to get the distance. When you're practicing, you go to this. Then from there, you try and you write down the formula that goes to that. So the formula that goes to the distance. Okay. You go to formula that needs to go to the distance there. You go to the gradient, you go to your formula sheet, you associate this formula, the gradient, with a formula for gradient. You go to the coordinates of the midpoint of the line, you go to your formula sheet, you then write down the coordinates of the midpoint, the formula there. The equation of the straight line, you go to your formula sheet. So all these are formulae that you need to understand and also be able to use them. The equation of the line also, there's the same thing, but you must know about the parallel and the perpendicular lines, what happens. So you write down your notes there. What happens to parallel lines? Same gradient. So what happens to the perpendicular lines? The gradients of line 1 times the gradient of line 2 will give you -1. And these are things that you need to understand so that you are able to pass the paper. Right. The examination guideline, I hope and trust you have that, and these are the things that you're going to see on your examination guideline, and these are the things that you're going to practice. You see, the angle of inclination, you must know what that is. You must know that the inclination has to do with the tangent of an angle equals to the gradient, so that you must know. You must also know the equation of the lines through center, with center 0, 0 and the origin, with the center at the origin of 0, 0. The tangent touching at only one point, then you're going to have a radius, and then you're going to have a tangent that you need to calculate the equation of. Okay, right. The points of intersection will also, you need to also go and practice that. That's your simultaneous equation. That's where you have your equation. Sometimes you have a straight line and a parabola graph. Then you need to calculate the values of x and y. Sometimes we have it in the circle and the straight line. You need to just substitute your equation of the straight line into the equation of the circle. This is a must, so everyone must get this one. This question will come as it is: x squared over a squared plus y squared over b squared equals to 1. This is a free 3 marks. Everybody must get this question. Okay, right. Just my target for this one, I wrote 18, but I just want us to get to 20. Okay, so now, how am I going to target my 20 marks? Okay, from the 25, I must target 20. So how am I going to target that? You must be able to use your formula sheet, which is provided. It is provided. So in other words, you must have it on the side of the question paper. That information sheet will be provided to you. So you have it. Please practice with that formula sheet. Do not memorize the formula sheet. Please practice with it. Right. So make sure that you understand the formula for gradient, which is m equals to y2 minus y1. Okay, I know you always want to write it on your own. Please check on the formula sheet, because we have seen formula written as x2 minus x1 over y2 minus y1, and that is not correct. Okay, the distance formula, you must be able to can figure it out. If, for instance, if I've got AB, it must have a square root. Okay, so in other words, we have x2 minus x1 or xb minus x, and then plus y2 minus minus y1, right? All squared. Okay, right. Make sure that if you started with x2 there, start with y2 there. If you started with x1 there, start with x1 there, y1 there. Okay. The midpoint of the line, remember that it is x2 plus x1, or x1 plus x2 divided by 2 for the x value. And then for the y value, it's going to be y1 plus y2 all over 2. It does not matter the order there, because if I add, the order does not matter. But when I subtract, you see there, I'm subtracting there, I'm subtracting, the order counts. Okay, so if I say y2 minus y1, I can't say x1 minus x2. In that way, in that order, my gradient is totally wrong. The equation of the straight line, y minus y1 equals to m into x minus x1. That is the easier one to get the equation of the straight line. Remember, you must be given the gradient, and you must also have the point, 1 point here, to get the equation. I know some of you might use y equals to x m in mx plus c. But with this one, remember, you must first calculate your c and then go back and write down the equation. Most of the time, most of you calculate the value of c, and then from there, voila, and then you leave out the equation. You don't write the equation, you end up at the value of c. So with this one, you substitute, and what comes out will be the equation of the straight line. The inclination of the line, inclination means nothing else but the angle there. So we will be talking to the angle which is on the x, between the x-axis and the line. So that angle that is there. But sometimes it is away from that line. We'll do one question based on that. This one, as said, it's a must. Everybody must know how to draw an ellipse. You must know how to draw an ellipse. Very, very important. It's 3 marks. That's free 3 marks. Right. Now let's look at some exam questions here. I've got an exam question, activity number 1 here. First of all, what you need to do is to read the statement. Read the statement and see if all what is in the statement is represented on the sketch. Very important. In the diagram, points A, it's minus 9 and 9. I go to my sketch, I check minus 9 and 9, it's fine. B is 3 and 5, so B is there is 3 and 5, that's fine. You have your C, which is 1 and minus 1, so 1 and minus 1, that's fine. And they say the vertices of a triangle. So here we are having triangle ABC. So I have that triangle there. It's P is the midpoint. You see, once they say it's a midpoint, so I know that this line and that line will be equal because it's the midpoint. So I can be able to get the coordinates of the midpoint of that line BC. Okay, and Q is on AB, so I was not told that there's a midpoint. So they say Q is that. All right, now, but because I've done my grade 10 and I understand my grade 10 work, I'll know that if this line here is equal to that line there, and this line is parallel to that line, therefore it means that Q will be the midpoint also. Okay, story for another day. Now, determine the gradients of AB and BC. So you see, the word gradient now appears. Now I go to my formula sheet. Please, please, please always go to your information sheet. So I go to my information sheet, copy the formula correctly. I now need the gradient of AB, which is going to be, so I go to my point A, I go to my point B there, so it's point A and point B. So then I work it out. So it will be 5 minus 9 divided by 3 plus 9. And that answer there will give me negative 1 over 3. So my gradient of now AB now is negative 1 over 3. How do I know I'm right? It is because this line here is increasing from the left of AB. Sorry, from the of AB. Sorry, I'm talking AB now. The graph here, the line here is decreasing. From my left, the line is decreasing. So if it's decreasing, it means that my gradient must be negative. You see, the line, I read it from the left to the right, is decreasing, decreasing, decreasing. So it's going down. The gradient should be negative. Then I know I'm correct. Let's check the gradient of BC. The gradient of BC. So the gradient of BC will be negative 1, negative 5 divided by 1, negative 3. If I check this, this gives me negative 6 over negative 2. The answer becomes 3. Let me check that gradient there. It's BC. That line is it's increasing from the left to the right. So meaning that the gradient is positive. Then I know I'm right. I'm definitely sure about my 4 marks. And that's how I get the 4 marks. Okay, so I'll get 1 mark for substitution, 1 mark for the answer, 1 mark substitution, 1 mark for the answer, and I get my 4 marks. No one with an information sheet must not do this question. So you must not skip this question. It's very, very, very easy. Right, now let's go to the next one. Now they say, is angle B equals to 90 degrees? Oh, I know you love these questions because you just say, it's either you say yes or no. And from there, you don't justify it. If you say yes or no, so if you say yes and then you get it right, then you have got 1 out of 2, which is 50% of that question. So at least you have passed it. So, but now you need to justify. Okay, if you say no, you get 0. So, and you even if you justify that angle is 90 degrees. So let's see if we can justify our answer. So if I say yes, in this case, I'm going to say I can say yes. Why? It is because, remember, we talked this line, the gradient of that line we know. The gradient of this line we know. Let's see if we multiply them, if we can get negative 1, then we are justified that that thing there will be 90 degrees. You see how you justify that. So we'll say, first of all, let me say the gradient of AB times the gradient of BC must give me negative 1. So let's check. What is the gradient of AB? I think we got it in the previous one. We said the gradient is a -1, so it's -1/3. The gradient of BC, we got a 3, which is the same as over 1. The 3 and the 3 cancels out, left with -1. Therefore, if my two gradients give me -1, it means AB will be perpendicular to BC. And if they're perpendicular, therefore it means that angle B there will be equals to 90 degrees. I've now justified that that angle is 90 degrees. Okay, you cannot just look at it and think, this one looks like 90 degrees, let me write 90. No. Remember, when we justify, we then need, don't write a story, don't write a paragraph. In technical maths, when we say justify, we want you to use numbers. Use numbers to justify what they're saying there. Okay, right. Getting right along. Now, the next question talks about the inclination. You still remember that? The inclination of the line. So inclination means angle. In this case, that angle, can you see where it is now? All right. So that one will serve as our, that one will serve as our x-axis. See that? So now I'll have this angle which is between the x-axis. Remember that line there and that line there are going to be parallel. Right, so that line here will now serve as the x-axis, and I need that angle there. But remember that angle is on this gradient, on that line, and I know the gradient of AB. Okay, so what I'm going to do, I'm going to just to say the tan of an angle is equals to the gradient of AB. See, because it's on the gradient of it, that's why you have those dotted lines. So I've got the gradient of AB, and I know what the gradient of AB is, -1/3. Now I need my calculator to get to that angle. So I'll then say, this angle here will be equals to, I go to my calculator and say shift tan 1/3. Please do not include that negative. So you'll say shift tan. This gives you the quadrant 3. Because I can see that that angle can never be 18 degrees. It's way more than 90 degrees. So it can never be 18 degrees. So therefore my angle will be 161.57 degrees. That is the value of beta. I think I'm correct here. The value of beta will be that angle. So you can see how we get the angle, the reference angle, where the angle is not on the x or on the y axis. Okay, right. So I can still get that angle here because I can just add the 161.57 with 18.43 degrees. Okay, right. And there's 2 marks. So 1 mark is for the gradient. So 1 mark will be for the reference angle. 1 mark will be for the final answer. Okay, because the gradient, we already have it in question 1.1. Okay. Now 1.4 says calculate the area. You see, these are the questions that we must get. You'll get these questions in paper 2. So you know your inclination, you'll get it. Go and practice it. You know, questions like area, sometimes they ask it, sometimes they don't. But if they ask it, then you need to know what to do. It's the area of the triangle. You're given the length of BC. I'm given the length of BC. That length of BC is 2√10. I know that this one is 90 degrees. I've already justified it. You see? Right. Even if I do not know, in question 1.2, they've already said, is B 90 degrees? Just take a guess and say, this is 90. Yes. Then from there, you know it's a right angle triangle. What do you need? I have a base. I need my height. So now, it means that I need the length of AB. So I'll go, you see how they ask this question sometimes, on the length. So now I need the length of AB. I go to my formula sheet and I got the distance formula, which is the length. So I'm going to then get the length of that. So I'm going to say it's going to be, so it will be 3 plus 9 all squared. Then I'm going to have plus into 5 a minus 9 all squared. So there will be 3 in minus into minus, 3 into minus there, right? So remember it's a minus, so I'm going to say 3 minus into minus 9, and I'm going to say 5 minus 9, and the answer that I'm going to get there, then from here, please use a calculator. Do not attempt to go there and write 12 squared plus minus 4 squared, and then from there you add them, and then you take the square root of that. From here, straight to the calculator, you get your answer. So you just put a square root, you put open bracket, 3 plus 9, close bracket, squared, plus 5 minus 9, close bracket, squared. Then the answer that you're going to get there is 410. Okay, so you write it like that. Don't write it in decimal. Don't write in decimal. Just write it in set form. It's easier because in decimal, then you're cutting the decimals in the middle, and then you don't write all the numbers after the comma and all that. So put it as in a set form. Then from there, how do I find the area? Remember, the area is half of the base multiplied by the height. In this case, my base, it's going to be 2 root 10 that is given. I'm multiplying by the height of 4 root 10, and then straight to the calculator. You see, straight to the calculator. Don't try to be smart and multiply half by this, and from there you put the answer, and then you forget which one you have multiplied with. Straight to the calculator, and the calculator will give you a 40. So the answer there is going to be 40. Okay, so 40 square units. Remember, it's area, so it will be 40 square units. Okay, lovely question here. All right. So in analytical geometry, as I said, all those formula, most of them, about 90% of those formula in the formula sheet, you are going to apply them in this section. Look at this. It says write down the midpoint. You see now, all those formula that I've talked about, they are appearing here. So midpoint. So what do I know about the midpoint of P? I need P, the midpoint of that. So how am I going to get the midpoint? 2 marks. So 2 marks means I can just work it out from the sketch and write down the answers. So I can just say the first one will be x. So it's 3 plus 1 divided by 2. So 3 plus 1 is 4 divided by 2. The coordinates of P will be 2 for this one. Then I can go there and say 5 plus minus 1, which is going to be 5 minus 1. It's 4. 4 divided by 2, it's 2. The coordinates of the midpoint will be that. So you have 1 mark for that, 1 mark for that. But I can still work it out and say x will be equals to 3 plus 1 divided by 2, which is 2. Then I'll then say the y value will be y equals to 5 plus into minus 1 over 2, which is going to be 2 also. Therefore, my coordinates of that will be 2 and 2. Remember, they said coordinates. So if you leave it there, these ones are not coordinates. If you leave it there, this is x equals to 2 and y equals to, these are not coordinates. So you must put it in coordinate form. Okay, right. So now you can see all the questions that it has to do with what we needed to, with all the formula that I talked about are there in this question paper. And in all the question papers that you have, that your teachers have sent to you, you need to go there and check those question papers and see if you don't see similar things that we were doing today, and do them and see how many marks you can get in analytical geometry. Right. Now, the next one says equation of PQ. What is PQ? It's a straight line. So in other words, what do I need? I need the equation of the straight line. So immediately I write down the formula, and you are going to have a mark for the formula. Y equals to that m into x minus x1. You see, I'll have a formula for the equation of the straight line. Now, I've seen the word parallel here, you see. And what do I know about parallel lines? The gradients are the same. So which lines are parallel? Let's see. Say if Q lies on AB and PQ is parallel to AC. Can you see? Right. So now, because I don't have the coordinates of Q, but of P I do have, remember coordinates of P is 2 and 2. But on this line here, AC, I have the points. So what can I do? If I know the gradient of this line here, it means I know the gradient of that line there, because they are parallel. So parallel lines have same gradient. So first of all, what should I do? I must first get the gradient of AC. Right. If I get the gradient of AC, I'll be able to can get the gradient of PQ. If I get the gradient of PQ, I've got 1 point, I can just substitute. Right, what is the gradient of AC? Let's check. It will be 9 subtract minus 1, which is going to be 9 plus 1. Then it will be minus 9 subtract negative 1. So I'll have 10 over negative 10, which is going to be negative 1. So the gradient of AC is negative 1. So because it's parallel to PQ, therefore it means that the gradient of PQ will also be negative 1. Okay. Now I can go to my formula now for the straight line, because that's what they want now. I'll say y minus the point on PQ, it's 2 and 2. My y value is 2. The gradient is negative 1. My x1 is going to be 2 also. All right. Then I'll have minus x plus 2. Transpose the other 2, I'll have plus 2 on the other side. Then I'll have a y, so y will be equals to negative x plus 4. That's a very, very, very straightforward question. So can you see the word gradient appears again? But now they didn't tell you to get a grade, the gradient of the line. They tell you about the using this word parallel. If they say it was perpendicular, it means that the two gradient must give you negative 1. So if you've got one gradient, you just turn it upside down, change the sign, voila, you have your gradient of the straight line. Right. Okay. Now, this question also is analytical geometry, and I'm counting the marks now. Already, if we've done that, we've got 6, 10, 12, 13, 14, 17. We already have 17 in that question. So we're running short of 3. Once we get 3, then we're covered. You remember, this is in your first hour. You are checking these questions that you have seen before, and you have practiced them, and you have practiced them. You've seen them in class, you have seen them in question papers, you have seen them in your formal test, in your informal test. These are the questions that we are going to start with. Now, 2.1, then it says, first of all, you must read the information and see if the information there is on the sketch. O is the center, yes. Line PQ is defined by the equation. What do I know about line PQ there? That line there is just a line. They didn't tell me it's a tangent, they just say it's a line. Okay. So now it's got a point P2 and negative 3 there. First question. Determine the equation of the circle. So you must understand and know those equations. Okay. Now the equation of the circle is x squared plus y squared equals to r squared. But because I do not have the r squared, but the x and the y I have, x and y I have, so I just need the r squared. So I just substitute. My x is 2 squared my y is negative 3 squared without the r squared. So now I'll have a 4 plus a 9, which is r squared. So my r squared is going to be 13. But most of you, and I'm warning you now, before we write on the 7th, to say the r squared equals to 13 is not the equation of the circle. It is only the r squared, which is 13. Then you must say, therefore, x squared plus y squared must be equals to 13. And most of you then come here and write square root of 13. The square root of 13 is the radius, but here we need a radius squared. So you must write the radius squared. From here, do not find the value of r here. Okay. Do not find the value of r. Right. Now, so that is the equation of the circle. So we've got 1 mark for substitution, 1 mark for the final answer. So if you stop here, you see you will not have a 1 mark, that 1 mark for the final answer. Okay, right. Okay. Now, here's a question that says we must justify. And as I said, with justify, do not write as a paragraph and explaining why it is not a tangent. Yeah, it doesn't look like a tangent. If it looks like a tangent, that line is going to pass there. No, we need you to justify by using numbers. Right. What do I understand about the line the line PQ being a tangent? If it is a tangent, it means that the gradient of the radius times the gradient of the tangent must give us -1. But we already know the equation because the equation was given to us. The equation of y equals to 3 over 4x minus 6. It's an equation of PQ, which means now the gradient of this line there, it's 3 over 4. Which means that I must calculate the gradient of that. If the gradient of this line is -4 over 3, therefore this is a tangent. Now let's check. The gradient of OP. By now you know the gradient of OP. If I've got O there and P there, the gradient of OP, just take the y value divided by the x value. You see now the gradient of OP is -3 over 2. But what is the gradient of the tangent? It's 3 over 4. Now you're asking me, where did he get the 3 over 4? No. You are given the equation of that line PQ as 3 over 4 minus 6. Which means that is the gradient of the tangent. So, not of the tangent, but of the line PQ. Now, if I take these two gradients and multiply them together, will I get -1? No, because I'm going to get -9 over 8, and which is not equals to -1. So I've justified using the numbers that PQ is not a tangent. For it to be a tangent, the gradients must be multiplied. The gradient of the radius times the gradient of the tangent must be equals to -1. But in this case, no, I justified it. We do not want to see paragraphs where you are justifying. Okay, justify by using the numbers. You must understand what does the tangent and the radius do. What is the relationship between the tangent and the radius in a circle? All right. Getting right along. Now, after doing that question, we are at 20 marks. Then this is a bonus question. It is a bonus question which everyone must be able to do. Every learner in Gauteng must be able to do this question after I'm doing it today. Right. It says draw on the grid below the graph defined by that. This graph will be like this. I'm not saying the numbers will be 20 and 9, please. I'm just saying this graph will be like this. Okay. Now, first of all, what do you do to draw this graph? You look at your 20. There's a square here. For me to get the x value, I must get the square root of 20. Okay. Which I think it will be 2 root 5. Okay. For the y value, I'm going to say that is the square root of 9, which is going to be 3. This is my y-axis. This is the x-axis. The nice thing about this question is that the graph, the Cartesian plane will be drawn for you. So you don't have to draw your Cartesian plane, because you know with you guys, when you draw your Cartesian plane, your units are not equal. The 1 is here, the 2 is there, the 3 is just next to the 2, and from there your ellipse doesn't look nice. Right, so 2 root 5, so meaning that it will be 2 times, it will be 4 comma something. So it means on my x value, I'm going to have 1, 2, 3, 4, I think 4 comma something there. I can put it there. Right, okay. When I finish that, then I write 2 root 5 there with a minus. I go on the other side and say 1, 2, 3, 4, 4 comma something is there. I write 2 root 5. Don't forget to write that, because it's plus or minus, remember. Okay, because it's x squared equals to, so x squared equals to plus or minus. Then I go to my y values and said plus minus 3. I go to 1, 2, 3. Here's 3. I write a 3 there. I go 1, 2, 3. I write a minus 3 there. Then I just connect these points, please, without a ruler. Then I connect that point. Then I connect this one. Then I connect that one. Then I have my ellipse, which is like that. So I'll have my ellipse like that. And the marks, 1 mark for the x-intercept, 1 mark for the y-intercept, 1 mark for the shape. That's a very simple, straightforward graph that everyone. So in other words, it means that we do not have anyone who's going to get a 0 on the question paper when we have a question like this, which comes every year. It will be like that. Okay. So on analytical geometry, out of 23 marks, we need to play around 18 and 20. If we can play around 18 to 20 in analytical geometry, and I've not taken some of those questions. I've just removed some of those questions that, I need a bit of a time to do, so that then you do those questions at the end of that paper. So you do them at the end. You don't do them during your first hour. During your first hour, you need to pass. So you need to do those questions that you see them every day. You have seen them in your question papers. You've seen them in class. You've seen them in informal tests and all that. Then after that, after an hour, then you can then go back and check those questions. Those questions, those complex questions. Then you do them. Then you pick up 1, 2 marks there and there. Okay. Now, trigonometry. 20 marks, we also need to target 20 marks. We say, candidates, you must be able to know those basic trigonometric ratios. Oh, the sine, the cosine, and the tangent. Those are basic ones. And again, you must know their reciprocals, which are the cosec. So we've got sine, we have the cosine, we have the tangent of an angle. Remember, it's an angle. And with their cofunctions, which is cosec. We have cos, which is sec. We have tangent, which is cot. So those are the reciprocals of those. Okay, you must know this. Now, we're going to also refer to the special angles, which I've seen that in the exam guideline is there. Okay, which obviously we know you use your calculators for this one, but we know you use your calculators on this one, which is fine. We can use the calculator to get that, and we know you're going to get your half or your square root of 3 over 1 over square root of 3 or square root of 3 over 2, good answers like that. You must be able to simplify the simple, because those ones are simple trigonometric expressions, and that's where you get easy marks. These are easy marks. Okay. That type of question here where you apply the sine rule and the cosine rule, those are questions that you can do them later after you have done your, after you've done your 70 marks. After you've done your 70 marks, you go back and do this type of questions, because sometimes they take time, they need you to think a bit and all that. But these other ones, you have seen them before, so you can be able to do them. The identities also, you have to look at them. These are the questions that I was talking about. This, I need every learner to get this question right. If they say draw a sketch, you must get that question right. If the sketch is given and you need to interpret the sketch to find the values of A or the values of Q, you must also be able to get it, because it's just substitution. Okay. Just take a point and substitute. Okay. Right. Our target marks, remember, today we are dealing with the target marks. These are the marks that we are targeting. In trigonometry, we want to target about 20 marks. Easy 20 marks in trigonometry. So already if I've got 20 in analytical geometry, I've got 20 here, I'm super. Now here it says, you must be able to determine the ratios given the Pythagoras type questions. You see, I'm wanting to find if I've got this type of questions, which are always there in an exam. In each and every paper, this question is there. It comes in 3 types or so, but it is there. So if you practice all the 3 types also, you are going to get one of those. Using reduction formula, I'm going to show you an easy way of doing that. The trig ratios, you must be able to solve the trig. To solve the trig equations. I wanted to write the equations, so it's equations, not trig ratios. Using a calculator, those are free marks. You have a calculator in front of you, just press. Drawing the trig graphs using a calculator and also interpreting them. So as I said, if they are drawn, you must be able to interpret. If you are requested to draw, please use a calculator to draw them. Okay. Activity number 1. I'm going to take this activity number 1. I'm going to take 2 minutes now for you to do activity 3, which is the usage of a calculator, and you just give me the answers for this one. And your 2 minutes is going to start now. Okay, we're back. Right, the question says, given the theta is 52.6, beta is 38.3 degrees. So now determine rounded off to 2 decimal places. So here, there is an instruction to round off our answers to 2 decimal places. First of all, I've got cosec, and I took my calculator and look at all those buttons and I could not locate cosec. So it means that I have a challenge there, which means because I know my reciprocals, I know that this cosec will be 1 over sine. So therefore, I'm first going to substitute for 52.6 minus 38.3 degrees. So if I substitute that, from there I write 1 over sine. So it will be 1 over sine of 14.3 degrees. On my calculator, I go to my fraction button, press 1 over sine 14.3. Because I don't have cosec on my calculator, which means that I need to use its reciprocal. So therefore, I hope and trust all your answers are the same. This question here, it's 3 marks. That one here, it's 2. Just swap the answers. So it will be 1 mark for substituting, 1 mark for changing that, 1 mark for the final answer. This one is not B, it's beta. Okay. So now, how am I going to do that one? So I'm just going to substitute also. So I'm going to substitute the cos of beta, which is 38.3, all divided by, okay, and the sine of beta, which is 38.3. But here now we've got a -1. Then I'm going to use my calculator. So on my calculator, I'm going to press the cos of 38.3, and at the numerator, I press sine of 38.3. Then I say equals to, then the answer there that I get, I subtract a 1. So my answer there is going to be 0,266. See, they said correct to 2 decimal places. That's correct to 2. Correct to 2 here will now be 0,27. Okay, so now the calculator work is where you can get your marks. You can get your 5 marks there, your 3 marks, whatever marks are there. Make sure that this marks you get. Even if there's written cot, just know that it's a reciprocal of tan. Use your tan. If you say it's sec, it's a reciprocal of cos. Know those. If you know those, because they're not going to be as straightforward as I've put for the second one here. They might write down the cos, sec, and cot. All right. The second one here, it says use a diagram. Sometimes they just say, given that, and then from there, determine the following. Then when you need to use the diagram. Hope you hear me here. There, cos of alpha is -3 over 5. So what do you know about cos? Your cos, remember, it's your SOHCAHTOA that you always sing, and some of us don't even know what you're saying. So the cos is adjacent over hypotenuse, which means the top number there with its sign there will be the adjacent. The bottom part will be the hypotenuse. So it means that if I draw my sketch, the -3 will be my adjacent side, the 5 will be my hypotenuse. So it means that I need the opposite. So I'm given an interval here which says alpha must be between 180 and 270. So if I draw my Cartesian plane, because your sketch must be in a Cartesian plane. If I draw my Cartesian plane here, I'll have a 90, I'll have a 180, I'll have a 270, I'll have a 360. So which means, in which quadrant will my sketch be? Obviously, if it's between 180 and 270, it must be in the third quadrant. I draw my sketch in the third quadrant with a 90 degrees, and the angle, remember, it's a reflex angle in the third quadrant. Now, meaning that now I must write down my angle is there. Remember, my angle is there. So this line here will be my adjacent. This is the opposite of the angle. So my opposite I don't have. The hypotenuse I have. The adjacent I have. So the adjacent side I have. So I just need to get my y value. Remember this thing here, we are working on a unit circle, which means that that thing there, I can be able to use the theorem of Pythagoras. Or with a right angle triangle, I can use the theorem of Pythagoras. So use the equation of the circle, does not matter. So now I need my y value. So my y value will be plus or minus 4. How did I get that? It's 5 squared minus into negative 3 squared, which is 25 minus, y squared, minus 9, which is 16. Y squared is 16. I have y equals to plus or minus 4 by taking square roots on both sides. Now, if I've got plus minus, then I check my y value. My y value is in the third quadrant, which makes it a negative. And this is where sometimes we lose marks. Because now when I come to this one, then if I put a plus sign, we will mark it right if you have worked it out here and then you have put it there. So we just follow it up. So, but you have lost a mark here. So make sure that you write it correctly because we don't want you to lose marks on this one. It's an easy question. The sine of alpha. So sine is going to be negative 4 over 5. The cos of alpha, I already have it there. It's negative 3 over 5. From here, you go to your calculator. Please, 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 please. You go to your calculator. You write down the answer. Don't be like me, but you go to your calculator. You write down your answer. Your answer is negative 7 over 5. Okay. Now, how am I going to get a cos? I mean, the sec alpha and the cot of alpha. The same. Sec is an opposite of cos. So meaning that it must be 5 over negative 3. So I can just write it like this. Cot is an opposite of tan. So my tan is going to be value of x over the value of y. The adjacent, you see, is a tower. It's an opposite side over the adjacent side. So it's going to be our opposite side over the adjacent. So the opposite side is minus 4. My adjacent is minus 3. But remember, we need a cot. So our cot here, it's not going to be that. So it must be, our cot must be negative 3 over negative 4. So that's my cot. So that one was my tangent. And this one is now my cot. So the cot will be minus 4 over 3, but the tangent will be minus 4 over 3. The cot will be minus 3 over 4. So from here, then I'm going to now work it out. Use a calculator, please. My answer will be 11 minus 11 over 12. Okay. All right. So this question comes every year. Sometimes this is how they bring the question. They will draw you a sketch, whether in the first quadrant or the second quadrant or third quadrant or fourth. They'll put a P there, maybe a negative 3 and 4. And this is OP. And they want you to get a length of OP. So the length of OP is your radius, it's your R in a unit circle. So you just substitute the value of X and your Y, you get your R. Then from there, you just connect this here. You'll have your angle, and then you can work out with your angle. See, sometimes they bring it like that. So please be wary of those two. Okay, right. The solving of trig equations, also key. This is easy. 5 easy marks. Transposing, dividing. You get marks for that. So if, for instance, I'm going to start like this. I'm going to say sine this equals to negative 0,753. See, I have that. Okay. The next thing is to divide everything there by 3 to get sine on its own. So it's negative 0,251. Okay. Right. Easy. The next thing that I'm going to do is to go to my calculator and write down the value of X, which is going to be my reference angle. This is easy 5 marks. I mean, already I've transposed, I've divided, I need a reference angle by using a calculator, and all my answers are there. So my reference angle there is going to be 14,54 degrees. That is my ref angle. Now I've got a mark for that. Now, the other mark will be 4. Now, listen carefully. These are not our answers. Did I give a mark for that now? So it's 1 mark there and 1 mark there. So the other 3 marks, look, listen to this. These are not your answers. The reason is the sign is negative. But 14,54 degrees is in the first quadrant where the sign is positive. So it means that I need to get quadrants where the sign is negative. So according to my cast, the sign is negative in the 3rd and the 4th quadrant. That's where it's negative. So which means in the 3rd quadrant, my solution will be, in the 3rd quadrant, it will be 180 degrees plus, remember the reduction formula, 14.54. That is in the 3rd quadrant. Okay. The other answer will be in the 4th quadrant, which is 360 degrees minus 14,54 degrees. Right? Which is in the 4th quadrant. Okay, if you understand this, you understand your cast, these questions will be a thing of the past. You'll get all these questions right. So now here I'm going to get 194.54 degrees. That's my final answer for that. That's your 1 mark there. And now I'll have my other mark there for the 360 degrees. Remember this for the 3rd quadrant. For the 4th quadrant there, I'm going to get 360 degrees minus 14,54. Then my answer becomes 345,46 degrees. See? Okay, these are easy questions. Easy questions, easy pickups. See? So these are the questions that I'm going to go to. In the first hour, I go to my question paper, look for this type of questions, do them, and then I relax. Then I do those ones that I think will give me a challenge, but I'll pick up marks there and there. That's the strategy of passing. Right. Now, here is another question that is a must for everyone to get. If you get this question, you must get it right. Now, why I say so? This 5 marks is the easy 5 marks, easy pickings. First of all, when you get this question, first thing that you do, you write tan x. So you write the tangent and this angle here, that is there. Next thing, you copy them as they are. Sine, put brackets, sine of x. Go to the bottom there. Sine. What is pi is 180 degrees. That you must know. In tech maths, that everybody must know that. Okay, especially when dealing with the angles here in trigonometry. It's 180 degrees minus x. So there you just put sine x. Right? There, what is that tan? You just repeat them as they are without these values. All right? You see, I've repeated them. Then I go to my calculator. This you're going to do that in an exam only. So I've already written that. Now I go to my calculator. I start with a tan. I'll say tan, open bracket, 180 degrees minus 1. I just say minus 1. The answer that I get has got a negative sign. That negative sign, I put it there. Okay, I need to put it there. Just behind the tan. You see? I'm done. So that 0, what I don't put even those answers because they said without using a calculator, but I'm using it. Now I'm done. So that one will be negative. Right. I go to the next one and I say sine 360 degrees minus 1. I just subtract a 1 from the angle. I get a minus. So it means that the sign will also be a minus. Then I'll go to the sine 180 minus. So I'll say sine 180 degrees minus 1. I get a positive value. So here it's positive. I don't even write it. But let me write it for this sign. Okay. Then the last one is what? Tan. I just say tan 180 degrees plus 1. Then equals to. I've got a positive value. So I'll just write just a positive. I'm done. How are we going to mark this? 1 mark, 1 mark, 1 mark, 1 mark. So you've got 4. The last mark will be 4. Oh, I can see the tangent cancels with the tangent. The sine cancels with the sine. Then the answer will be negative times negative is positive. The answer is 1. That's the 5th mark. See, I've used the calculator and no one knows. Oh, it's me and you that knows. Okay. But the examiner will not know. Okay, that I've used the calculator. Because I don't have any decimals. I don't have any numbers. I don't put any numbers. I've just worked on the sign. Okay. Right. So this is the type of question that everyone must get. If these things that do not cancel, for instance, and you see a tan, change that tan to sine of x over cos of x. That is tan. Then, if they do not cancel, so that you can get that 1 mark there. But for now, because I can see the tangent and tangent cancel, it's fine. Okay, right. To repeat, you write this ratios as they are without the numbers. Then from there you put them there, and then from there you start there. You say tan 180 degrees minus 1, minus 1, plus 1, minus 1. Then you do it individually so that you can get the sign of that answer. If the sign is negative, you put a negative. If the sign is positive, you put a positive. And you're done. That's 5 marks. Sometimes this question carries around 9 marks. So this is a bonus. Right. The last part of trigonometry, it's this. Graphs. I'm not going to spend a lot of time on graphs because that you can go and do with your calculators. Given the function f at x equals to this, cos of 2x for g of x, where the graph starts from 0 to 180 degrees. Write down the period of g. Now, the period of g, what does the period mean? It means that the complete graph. Where are we going to finish? How many graphs are we going to have there? In this case, you have got cos 2x. For you to get the period, because the period of the cos graph, it's always 360 degrees. Always. Then you take the 360 degrees, you divide it by that 2. that will give you the period of this graph. So that will be 180. So what does this mean? It means that at 180 degrees, we have a complete graph. That's what the period means. So if I had cos of theta, cos of x, y equals to cos x, therefore my period will be 360, because at 360, from 0 to 360, I'll have a complete graph. But that graph, because it's got a 2 there, I divide that period by 2 to have a full graph. So I'll have that. Easy. Right. Now, how am I going to do this graph? Use a calculator. I know some of the teachers have already done it with you, the calculator usage, where you press your mode, your table, and from there you put the graphs in and all that. Okay. If you have not done that, we have a 0 here. I'm going to use the 45 here. I'm going to use the 90 degrees, 135, and I'm going to use the the 180 degrees. Right. If they've not done that, so you take the sine graph, y equals to sine x. You substitute by all these values, by 0. So in other words, substitute by 0, by 45, by 90, by 135, and by 180. You do the same with the graph of cos of 2x. You substitute by all these values here. Okay. So if I substitute by 0 on my sine graph, I'll get a 0. I substitute by 45, I got a 1. I substitute by 90, I got a 0.77 somewhere there, right? And I substitute by 135. So I've got a graph like that. So I'm going to substitute that one by 135. I did not substitute by 135 on my graph here. So here I'm going to have at 90, I'm going to have 41, sorry. That point is not there, right? So at 45, I'm going to get that. Okay, let me just erase this because I'm now messing up my graph. Okay, can you take a minute?
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much.
Okay, sorry about that. Some technology glitch there. The points that we were talking about there, it was 0 at 0, at 45 is going to be 0.7, at 90 is going to be 1, at 135 is going to be 0.707, at 180 there it's going to be 0. So in other words, I'm going to join my graph. So that is my sine graph. So if you look at that sine graph, it's not a complete graph, right? So that is the graph of f, right? Now let's look at the other graph, the graph of y equals to cos 2 of x. So this one, we're going to substitute again by 0. We substitute by 0, by 45, we substitute by 90, you substitute by 135, and by 180. So if I do that, my graph is going to start at 1 if I substitute by 0. Then it's going to come to 45 if I substitute there. Then I'm going to have a graph there at that point, and I'm going to have a graph there, and I'm going to have a point here. So which means my graph is going to go like this, go like that, using my calculator. And then from there, I stop there. My graph stops there. Don't make arrows, no arrows on this graph, because that's where it stops. So you can see that G graph, it's a shape of the normal cos graph that we know. So meaning that at 180, it's a complete graph. That's why our period was 180 degrees. Okay, hope you get that. Now, so that is our targeted 20 marks. So if you can get that 20 marks, then you're fine. You were 20 analytical, 20 there in trigonometry. Now I'm moving. I've got 40 marks. I need 45, but I just need to go to 70 at least. Right. This is one of the topics that you also need to get marks, because this question, the formulae are there. I've cut out the formula sheet here in the middle of the formula sheet. This is where you get this formula. Look at this formula. That formula is there. It's written omega equals to 2 pi n. And they tell you that formula is for angular velocity. So it means that if they ask you in the question paper, they say calculate the angular velocity, I go straight to this formula. If they say circumferential velocity, or sometimes they call it a peripheral velocity. Peripheral velocity. So you go there to this formula and then you write down that formula. It tells you D is for what, N is for what, N is for what. So it tells you. There they tell you this is the formula for finding the arc length, where theta is the central angle. So in other words, I must have a central angle here. There must be a central angle. And R is the radius, so you must have a radius here. Okay, area of the sector. These are the formula. This is the formula also for the height, for the diameter, for the length of the chord. In other words, you must have a circle also for that formula to work. Okay. So these are is a repetition of what I'm talking about. Targeted marks, 20 marks. We must know the formula for angular velocity, circumferential velocity, length of chords, arc length, area of the segments. I get 20 marks. Let's look at the questions. First question. You see, it says, calculate, you're given that scenario. A helicopter, as shown in the picture, has a rotating blades with a radius of 16 meters. You're given the radius, and you know the relationship between the radius and the diameter. Okay, so they say calculate the radius. You're given the radius. And it rotates at 205 revolutions per minute. Conversion is very important. You must know that. How many seconds do we have in a minute? How many minutes do I have in an hour? How many hours do I have in a day? So those conversions, you must know them. Here they say calculate the circumferential velocity in meters per second. Here I'm given per minute. So meaning that my minutes must be broken down to seconds. So how do I break down minutes to seconds? Divide by 60. So already I know that my 205 must be divided by 60. Okay. The radius there, I have a radius of 16. So if they want a diameter, if my formula needs a diameter, I just multiply it by 2. So it's very, very important that you read the question, understand, and break it down and write down things. Okay, right. Circumferential velocity, I go to my formula sheet. Circumferential velocity is there. Here's the formula. Write down the formula. Let me write down the formula. Okay. Right. So I'm going to write down the formula as it is. Velocity equals to pi dn. Now, what do I know? Pi, it remains like that. The diameter, I'm given a radius. What should I do? Multiply that one by 2. So that will give me 32. The number of revolutions are given per minute. I want them per second. So meaning that I must break down this per minute to that seconds. Okay? Right, and then I just use my calculator. 1 mark for this, 1 mark for substituting, 1 mark for changing that. And then from there, I just use my calculator, which gives me 343,48. Then what am I going to write? Meters per second now, not meters per minute, because I've already changed it. Okay, makes sense, perfect sense. Okay, right. The next one says angular velocity. Do you remember the formula for angular velocity? You go to your formula sheet, is written angular velocity. I write it down. Omega equals to 2 pi n. So the only thing I substitute here is my number of revolutions. And remember, they were in minutes, but I need radians per second. So it's 205 over 60 seconds. Then I just write down my answer is 21.47. That is radians per second. 1 mark for formula, 1 mark for substitution, 1 mark for the final answer. These are easy marks. I mean, the 20 marks we can be able to get in this question. No doubt about it. Right. Now here, it says there's a car which is stuck in the mud. Don't worry about the car. Just worry about what they say about that. Those numbers, I'm given an angle of 245 here. So if I need that angle here, I can just subtract from 360 and I'll get 105. I just want to write it there. PT is perpendicular to OT. So meaning that angle is 90 degrees. I can use Pythagoras theorem as I need. Okay, and I already know that this line and that line are equal. The length of the radius of the wheel, including the tire, OQ. So OQ, it's 65. It's given. It's there on the sketch. The wheel is RT equals to 28. So the wheel is this one. This part is the wheel. So it's 28. I know that one is going to be my height. Already I just know that will be my height of the wheel. Calculate the length of PQ. So I need the length of this. What is that line there? It's called a chord. If I go to my formula sheet, J in the middle, I see there's a formula that talks about the length of the chord. I use that formula. That formula is 4h squared minus 4 multiplied by d multiplied by h plus x squared equals to 0. So already I've got my diameter. Because I've got a radius, I can get my diameter. Then I've got my height, which is that one, 28 centimeters, the height of the wheel. Then I need the length of the chord in this case. So I just substitute. This is 28 squared minus 4 times the diameter. Now it's going to be 130. My height is 28. Plus x squared, because in that formula it says x is the length of the chord. Can you see that the formula sheet helps you so much? Information sheet. So we have got x squared equals to, I'm just going to, I've already multiplied everything there, 4 times 28 squared minus this, so I get 11,424. Therefore, x will be equals to, don't do a plus or minus because it's the length. So with the length, it's a positive value, which is 106.88. So it's in centimeters, so I just write it in centimeters, meaning that the length of PQ will be 106.88. Okay, so you can see it's just formula substitute. Okay. Write down the size of POQ. Oh, POQ, we've already got that one. So we said that angle there is going to be 105 degrees. Okay, no problem with that. Hence, you see the hence means use the information that you got in that to convert POQ to radians. So remember, how do I convert to radians? It's multiplied by pi over 180 degrees. Remember the pi must be on top, the angle at the bottom, okay? Then I get I think it's 1.83 radians. 1.83 radians. There's 2 marks. One for substitute for doing that, and then 1 mark for the answer. Okay. The length of the minor arc. So arc length, remember the formula, it's r theta. So the theta here, the radius is 65. The theta is the angle that I got here in radians. Remember, it must always be in radians. Okay, and then now for me to get the answer is 118.95. So this is the arc length. The arc length of this thing here. Okay, right. The area, remember the area, it's going to be the r squared. So here is just formula and substitute. Formula and substitute only. Once you know which formula to use, then you are fine. The area, and it's written there. What is r? 65 squared. What is my theta? It's 1.83. Remember, I used radians here. I don't use angles. I don't use degrees here. I use radians. Unless if it is given that I must use degrees. Right. So if I calculate that, use a calculator, therefore you get 3865.88. Is it centimeters? Yes, centimeters squared. Okay. So we calculate the area of the minor segment. So in other words, I just need the area of this part here, which is the minor segment, which is that. So that's the area of the wheel. Okay. Right. The last question that I'm going to do, it's all about another question that comes every year and we are struggling to get it right. Here it talks about a pothole that was discovered on a national road. I also have next to my house there is a big pothole like this one. It reminds me of that pothole. The diagram shows the irregular face. See the irregular face. You see, it's not a rectangle or a triangle of a pothole. It's just a irregular. Okay. It's a 23-meter long. So in other words, the coordinates of that, so they've divided that into parts, into these equal parts. So now we need to find the length of each part. Easy. You take the 23 centimeters, the length of that, then you divide it by these parts, 1, 2, 3, 4, 5, 6. So we've got 6 parts, so you divide it by 6, which gives you 3.83 centimeters. That's the 1 mark. Okay. Then you calculate the area of the face of the deck. So you remember the formula. The formula is the end of the formula sheet, which talks about the midpoint. Okay. So the A value, because the formula has got an A value. So what will be your A value? It will be 3.83. Then you take the midpoints of all those, divide them by 2. So what am I going to have? I'm going to have 4 plus 12 divided by 2 plus 12 plus 14 divided by 2 plus 14 plus 15 divided by 2 plus 15 plus 17 divided by 2. So easy. Plus 17 plus 19 divided by 2, or by 9, sorry, divided by 2. And the last one is 9 plus 5 divided by 2. And then from there, I get my answer 241.67. Simple as that. Okay, so I just take the midpoints of that. 4 plus this, 12 plus this, 14 plus this plus that, then I get all the values. Okay, then there's the area. And then lastly, last question there is the volume. What is volume, by the way, is the area multiplied by the height. Remember, is the area of the is multiplied by the height. Already I'm given the height. I know what the volume is. I mean, the area is. The height of that pothole is 8. So it means that now they want to fill in that, they want to fill in the pothole. They want to fix the pothole. So they must calculate the depth, the depth of that pothole. So the answer there is going to be 1933.86 cubic centimeters. Okay, so my boys and girls, these are the questions that you must look for in an exam. And if you get these questions right, you've already passed. With these questions that I've done today, you've already passed. So you go there, you check for those questions. Each and every question paper that you practice with, check this type of questions, start with them, and the rest you do them after maybe an hour or 1.5 hours. Then that's where you can do the other questions. These ones are for you to get 70 marks out of 150 degrees. I'd like to take this opportunity to thank you and wishing you good luck in your paper 1 and paper 2. Thank you so much.